Hello friends, happy 2025. Today I would like to give a shout out to my new subscribers including my Indian friends. I have realized that most of my new subscribers are from India. Thank you so much family for believing in my work and supporting it. One of my subscribers, a student of sugar technology in India, had requested that I do a video on steam consumption in sugar industry. I believe this video will help him and others who are in the field of sugar industry. Steam consumption is a wide topic and I'll cover it in two videos. In today's video, I have focused on steam consumption of a factory that has quadruple effect evaporator system without vapor bleeding. Live steam is formed in boilers where bagasse is burned to produce heat energy which boil water to high pressure steam. So this high pressure steam is what we call live steam. Live steam produced is used to drive the turbine so that it generates electricity that can be used for lighting and other activities. Steam that has already been used in driving turbine has less pressure and is referred to as exhaust steam. This exhaust steam is the one used to heat materials in the factory. Exhaust steam is used to heat sugarcane juice in order to raise its temperature, concentrate it, initiate sugar crystallization and dry sugar crystals formed. As steam loses its heat to materials in the heating vessels, it is converted to condensate. It is important to calculate the quantity of steam used in the factory in order to determine the cost of production as well as the efficiency of the heating vessels. When I say quadruple effect evaporator system, I mean the evaporation section of that factory has four bodies, that is evaporator 1, 2, 3 and 4. To get more explanation on evaporation, kindly watch my video on evaporation. Vapor bleeding is a process in a multiple effect evaporator system where a portion of the vapor produced in one vessel is diverted away to heat materials in other sections. For example, vapor from evaporator body 1 can be used to heat materials at pan floor. So in today's case, I'm concentrating on a factory that does not divert its vapor to other sections. So to get the total steam consumed in factory, you will take steam consumed at juice heaters plus steam consumed at evaporation section plus steam consumed at pan floor plus steam consumed at centrifugals. First, let's calculate steam consumed by juice heaters. Remember, raw juice or mixed juice from milling section has a temperature of around 30 degrees Celsius. This temperature has to be raised to around 105 degrees Celsius for easy liming and clarification. So the formula of calculating the quantity of steam required for heating juice per hour is equals to quantity of juice flow in tons per hour times specific heat capacity of juice in kilocalories per kg degrees Celsius times temperature rise of juice in degrees Celsius over latent heat of the heating steam in kilocalories per kg. Specific heat capacity is the amount of heat required to raise temperature of 1 kg of a substance by 1 degrees Celsius. So the specific heat capacity of sugarcane juice is 0.9. Latent heat is the amount of energy absorbed or released when a substance changes phase at a constant temperature. When steam releases heat energy to juice, it changes phase from gaseous state to liquid state. That heat energy released when it's converting is what we call latent heat of vaporization. Latent heat of vaporization of steam varies depending on its temperature or pressure. So to get the latent heat of steam of a specific temperature or pressure, you need to consult the steam table which I have attached at the end of the video. Heating without vapor bleeding system use exhaust steam of the same pressure, hence latent heat of vaporization will be the same for all juices. Assuming that exhaust steam of 1.5 kg per centimeter squared was used, the latent heat of vaporization for this steam according to our steam table will be 531.73. The table below shows the materials and parameters which be needed to calculate amount of steam used at juice treatment section. First, we have raw juice or mixed juice. This juice comes from milling section and its initial temperature is 30 degrees Celsius. The temperature of this mixed juice has to be raised from 30 to 75 degrees Celsius before it enters the liming tank. The second one is lime juice. This juice comes from liming tank and its temperature is 70. This temperature of 70 has to be raised to 105 degrees Celsius. The third one is clear juice. When clear juice comes from clarifier, its temperature has to be raised from 95 degrees Celsius to 110 degrees Celsius before it enters evaporator 1. The quantity of raw juice per hour was approximately 130.23. The quantity of lime juice was approximately 131.79. The quantity of preheated clear juice per hour was 126.66. We have all the parameters needed for calculating quantity of steam used by juice heaters. We'll start with raw juice or mixed juice. So for our mixed juice, the quantity of mixed juice per hour, we have said it is 130.23 times the specific heat capacity of juice is 0.9 times temperature change, which is, we said the initial temperature of mixed juice was 30 and after heating the final temperature was 75. So we'll take 75 minus 30. You'll get that's 45. So we'll take 130.23 times 0.9 times 45 over 531.73. This one will give us 9.92. So 9.92 is the steam used to heat raw juice or mixed juice. Next, we have lime juice. The quantity of lime juice per hour is 131.79 times the specific heat capacity of juice is 0.9 times temperature change. I say that the initial temperature of lime juice was 70 and after heating the temperature raised to 105. So we'll take 105 minus 70, you get 35. So we'll take 131.79 times 0.9 times 35 over 531.73. That one will give us 7.81. So the quantity of steam used to heat lime juice was 7.81. The next one is clear juice from the heaters. The quantity of clear juice I've said is 126.66. The specific heat capacity of juice is 0.9. The temperature change, I say that the initial temperature of clear juice was 95 and the final temperature after heating was 110. So to get the temperature change, you take 110 minus 95, that's 15. To get the quantity of steam of clear juice, you take 126.66 times 0.9 times 15 over 531.73. This one will give us 3.22. So the quantity of steam used to heat clear juice is 3.22. So to get the total steam consumed by juice heaters, you will take 9.92 plus 7.81 plus 3.22, which is equals to 20.95 tons per hour. So in 1 hour, the steam consumed by juice heaters is 20.95. Let's now calculate the quantity of steam used in evaporators. Remember, the formula used in calculating steam in juice heaters is not the same as that of evaporators. This because in juice heaters, the main aim is just to raise temperature for easy liming and clarification. But in evaporators, the main aim is to remove water from juice to raise its bricks from around 13 to around 60. So the formula of calculating steam consumed at evaporators is total water evaporated in a multiple effect evaporator divided by number of effects. For our case, the number of effects is 4 because we have 4 evaporation bodies. So to get the amount of water evaporated from juice, you will take bricks of syrup minus bricks of clear juice divided by bricks of syrup times 100. For example, if the bricks of our clear juice is 13.4 and bricks of syrup is 58, you'll take 58 minus 13.4 over 58 times 100, which is equals to 76.9. That means the amount of water evaporated was 76.90. So to calculate the steam consumed, you'll take 76.90 divided by 4, which is equals to 19.23 tons per hour. Let's calculate the quantity of steam used in pans. Steam used for mass acute heating is equals to constant coefficient factor, which is 1.5, times quantity of mass acute heated per hour, times bracket bricks of mass acute minus bricks of seed material. Remember, seed material can be syrup, A molasses, or B molasses, divided by bricks of the same mass acute. The table below shows the materials, bricks of materials and quantity of materials in tons per hour. Remember, these values will help us to calculate the quantity of steam used in pans. The table below shows the materials, bricks of materials and the quantity of materials in tons per hour. First we have syrup. The bricks of syrup is 58.00. Next we have emacecute. Bricks of emacecute is 92.50 and its quantity is 33.48. Next is molasses. The bricks is 78.55. Next is B macecute. Bricks is 94.80 and quantity is 14.34. Next is B molasses. Bricks is 81.46. Next, we have C macecute. Bricks is 97.00 and quantity 9.57. Let's calculate the quantity of steam used to heat each macecute per hour. So for A macecute is equals to 1.5, which is the coefficient factor, times 33.48, which is the quantity of A macecute heated per hour, times bracket 92.5, which is the bricks of A macecute, minus 58, which is the bricks of syrup, divided by 92.5. This one gives us 18.73. Quantity of steam for B macecute is equals to 1.5, which is coefficient factor, times 14.34, which is the quantity of B macecute heated per hour, times bracket 94.8, which is bricks of B macecute, minus 78.55, which is the bricks of A molasses. Remember, A molasses is used to prepare B macecute. Divide by 94.8. This one gives us 3.69. Quantity of steam for C macecute is equals to 1.5, which is coefficient factor, times 9.57, which is the quantity of C macecute heated per hour, times bracket 97.00, which is the bricks of C macecute, minus 81.46, which is the bricks of B molasses. Remember, B molasses is used to prepare C macecute. Divide by 97.00. This one gives us 2.30. So to get the total quantity of steam used at pan flow per hour is equals to 18.73 plus 3.69 plus 2.30, which is equals to 24.72. Steam used as centrifugos is estimated at 5% Ken. Remember, steam is used as centrifugal to dry sugar crystals. We'll use this percentage to calculate quantity of steam used at centrifugos. So in case the TCD or total cane crushed on that day was 2,700 and crushing hours were 22 hours, steam consumed on that day will be 5 over 100 times 2,700, which is equals to 135 tons. Remember, this is for the whole day. So to get steam used per hour, you'll take 135 divided by 22, which is equals to 6.14. So to get the total quantity of steam used, we'll take steam used at juice heaters, which is 20.95, plus steam used at evaporators, which is 19.23, plus steam used at pan flow, which is 24.72, plus steam used at centrifugals, which is 6.14. This one will give us 71.04 tons per hour. Recommended steam consumption without vapor bleeding for sugar plant is between 57 to 61% Ken. For example, our steam consumed in an hour was 71.04. To get per day, we'll take these times crushing hours, which is 71.04 times 22 will give us 1562.88. So to get steam percent Ken, we'll take the quantity of steam used per day divide by the quantity of cane crushed times 100, which is 1562.88 divided by 2,700 times 100. This one will give us 57.88%. That means that the steam consumed on that day was within the range. Attached is the steam table and reference of reading materials.